Let's now take a look at the inverse of this exponential function. So I'm going to very quickly find the inverse of the exponential function, and I'll show all the steps. So here it is. We start with 5 to the x plus 4 power minus 2. Switch our x's and y's, solve for y. Notice right here in this step, we switch to a logarithm now that we have a to the b equals c. All right, so we end up subtracting 4, and we get the log function log base 5 of x plus 2 minus 4 equals y. I've also included some information to remind us of our analysis from the exponential function. We'll look at that at the very end. Okay, and let me get myself out of the way right here. All right, so here's our log function, log base 5 of x plus 2 minus 4. And the first thing I want you to notice is it's really difficult to spot integer coordinates on a log function. All right, so it was a lot easier to do with the exponential function. And that's because the log function is really solving for those exponents, and that's tough. All right, but I've spotted one right here at -1, -4. All right, which is cool to spot one at -1, -4, because I had one. I had a point of -4, -1. All right, so you can tell that they are inverse points. I also went ahead and just tested. Well, if I had a point 0, 623 in my exponential table, I should have 623, 0 in my logarithmic table. All right, so that the table helps us find the y-intercept 0, -4, and the x-intercept 623, 0. All right, domain. The domain of the log function looks to be limited at -2, and I went ahead and graphed a vertical asymptote. I'm getting ahead of myself, but it looks like there is no x value past -2, so it's restricted to numbers greater than -2. And the reason for that is, if you look at the log function, you cannot have 0 as, for example, you cannot have the log of 0, because 5 to no power in this world will ever get 0. There's a horizontal asymptote for exponential functions. You cannot get an exponential output that is 0 or less. All right, so I cannot have 0 in to be an output to be used inside of the parentheses. So that's why -2 is the boundary right there. All right. As far as the domain goes, it'll be -2 to infinity. The range is unlimited, -infinity to infinity. Then that helps us see, well, we have a vertical asymptote at x equals -2. I hope that you're starting to see some connections to the exponential function. All right. Then we get to the end behavior. The left end behavior is as x goes to -2. Right. Notice x cannot go to -infinity if you can't approach -infinity in the domain. So the left end behavior is as x goes to -2, y goes to -infinity, and as x goes to positive infinity, y goes to positive infinity, slowly but surely. All right. Then transformations from log x, the function goes down 4 and left 2. So that's the information. Let's compare our analysis from exponential. So here's a full comparison. And I mistakenly said that the y-intercept was 0, -4. It's 0, -3.57. Thus, you can see that it's the inverse of the x-intercept of the exponential function. All right, but you can see that our table is reflected. Now, I will say one thing about logarithmic tables. It's hard to find integer coordinates. All right, so just know that it increases at a very slow rate. All right, for example, I had to jump up to 623 to find the 0. All right, so make note of that. Be patient. Try to evaluate logarithms. Domain 2 to infinity, range -infinity to infinity. Look at the comparison. Look at how the domain and the range are swapped between the exponential function and their logarithmic function. Also, the exponential function had a horizontal asymptote at y equals -2. Well, the logarithmic function has a vertical asymptote at x equals -2. And then this part's amazing. The end behavior, it's literally switched. As x goes to -2, y goes to -infinity, because you can't approach -infinity on the x-axis. So x can only go to -2. Notice how that is switched, that's inverted from the left end behavior of exponential. The right end behavior, as x goes to positive infinity, y goes to positive infinity. And in the last 20 seconds, if you want to find integer coordinates, if you're struggling with that, make the argument of your function, meaning this part, make it equal to powers of 5. So for example, 3 plus 2 is a power of 5. That way log base 5 of 5 is 1. 1 minus 4 is -3. Or 23 plus 2, which is 25. Try those out.